Good morning students. In this class we are discussing about the hybrid pi parameters. So this is the hybrid pi model of CE configuration. Okay. So this is the diagram for hybrid pi model RBB dash, RB dash E, CE, CC, RB dash C, GMBB dash E and RCE. So first we have to find out the resistive parameters. The first one is RB dash E, that is input resistance, or input conductance, that is GB dash E. Here we are considering both H parameters and hybrid model of CE configuration. Okay. So this figure shows the H parameter of CE. So this is the simple H parameter of CE configuration. By applying KCL at the output circuit, we can write the equation HFE IB plus HOE VCE minus IC is equal to 0. Here currents are in opposite direction, that's why minus IC. So the equation can be written as IC is equal to HFE IB plus HOE VCE. Okay. Making VCE is 0, the output is short circuited. Making VCE 0, the output is short circuited, and the short circuit current gain can be written as HFE is equal to IC by IB. This is equation 1. Okay. Next. Now draw the hybrid pi model of CE configuration. We are finding out the resistive parameters. We derive the equations for the resistive parameters. So here we neglect the capacitive elements. So the circuit can become, so this circuit, hybrid pi model can be redrawn as hybrid pi model. RBB dash, RB dash E, RB dash C, GMBB dash E and RCE. So this is IC current, collector terminal, IB input current, base, this is the virtual base, emitter and collector. Hybrid pi model by considering only resistive parameters. Here RB dash C value is 4 mega ohms. RB dash C is 4 mega ohms. So the current flows in RB dash E. Directly the current flows in RB dash E. So here VB dash E is equal to VB dash E is equal to V is equal to I into R. IB into RB dash E. Okay. Next. IC is equal to, here IC is equal to GMBB dash E. So GM is equal to IB into RB dash E. So IC by IB is equal to IC by IB is equal to GM RB dash E. From equation 1, IC by IB can be written as HFE. So by using this, HFE is equal to GM RB dash E. So from this equation, we can write this RB dash E is equal to HFE by GM. Okay. The input resistance RB dash E is equal to HFE by GM. So for input conductance, GB dash E is equal to GM by HFE. GB dash E is equal to GM by HFE. This is the derivation part for input conductance 𝐺𝐵'(E). So the second important equation from unit 2 is 𝐺𝐵'(E) is equal to Gm/HFE. Okay. So first we have to draw the hybrid pi model of CE configuration. After that we have to find out the resistive parameters, that is RB'(E), the input resistance or input conductance. For this we have to draw the H parameter of CE configuration by applying KCL at the output port. By applying KCL at the output port, we write the equation and find out the current gain HFE. After that we draw the hybrid pi model of CE configuration by neglecting the capacitive elements. So this is the derivation. So here VB'(E) is equal to I into R, means IB into RB'(E). Again IC, here IC is equal to GM/VB'(E). So GM into IB into RB'(E). IC by IB is equal to HFE. So HFE GM RB'(E). So finally RB'(E) is equal to HFE by GM.